there we are. Topic 5.3, page 266. In problems 1 through 4, identify the numerator and the denominator of each rational number. So problem 2, 4 is the numerator. It's telling you how many. And 5 is the denominator, or the denominations, what kind. We've divided a pie into fifths, and I'm going to eat, if it's apple pie, 4/5 of it. And you get 1/5. That's just the way it is, because I'm the teacher. I get to choose. So, denominator, numerator. Question 4. What's the numerator? Don't forget that negative. Negative 4. What's the denominator? 5. So here, I just put 3 on here. 3 is the numerator. So what's the denominator? 3 over what? 1. See, if you just see a number by itself, then the denominator is always 1. When you turn it into a fraction, isn't that what they're calling these? Well, rational numbers. You probably know them more as fractions. So if I see it, like for example, let's just do another one. Here's 6. So that's the numerator, because that's telling me how many. What's the denominator? 1. You follow me? Okay. Problems 5 through 7. Identify the rational numbers that are equal. Oh man. I need to get my calculator out for this one. Because when it says problem number 6 is the one I have up here, by using the definition of equality, here's the definition of equality. A over B equals C over D if A times D equals B times C. So what happens is, you do this times this, whoops, change color again. This times this equals this times this. So let's just take problems number 6, and what does it say? 438 times 23. So what's 438 times 23? What does that equal? 10074. Can you remember that? Or write it down? 10074. Now I take 529 times 19. What does that equal? 10051. Do they match? Did 438 times 23 equal 529 times 19? No. So these are not equal. Then let's try these two. 19 over 23 and 322 over 391. 19 times 391 equals, what'd you get? 7,429. Write that down. 7,429. Then I take 23 times 322 equals 7,406. Is that what we got before? What was the other answer? Was it 7,409? So those don't match either. So this number doesn't equal this one. This one doesn't equal this one. The only other thing to check to see is if these two are equal. So I take 438 times 391 equals 171,258. Everybody, yes?
19 over 23 and 322.
They did equal? Oh, I made a mistake. 19 times 391 equals 7429, and 23 times 322, I get 7406. 23 times 322,
323.
what?
It's 323 in the book.
It's what?
323 in the book.
Oh, I copied the problem down wrong? Well, no wonder it's not working for me, huh? This should be 323.
Yeah.
Well, let's see what happens now. Now we go 19 times 391, and it equals 7429. And what's 23 times 323? 7429? Yeah. So make sure you copy the problems down right. Now see, it used to be, when I was younger, I did stuff like this on purpose. So you would realize how you can make a mistake by copying the problem down wrong. But now that I'm older, I don't have to do it on purpose anymore. I make enough mistakes that they just pop up and show you that you have to be careful with this stuff. So that means these two are equal. You follow the process? Good. Then let's move down to problem number 8. Problems 8 through 16. Reduce each fraction to lowest terms. Remember what we learned in the last class about reducing? 14 is 2 times 7, and 21 is 3 times 7. Did I see a question somewhere? And the 7s will cancel. That's a name for 1. So the answer is 2/3. Everybody follow that? Number 10. 42 is 2 times 21, and 21 is 2 times 3 times 7. Everybody follow the process? And 86 is 2 times 43. Can I reduce 43? Keep your little prime number chart handy. It'll save you some time. Is 43 on there? Sure enough. So I know 43 is the prime number. So now what will cancel? The 2. So that leaves me with 3 times 7, which is 21, over 43. Follow the process? Number 12. 15 is 3 times 5. 12 is 3 times 4. The 3's cancel. So I'm left with 5 over 4. Number 14. 22 is 2 times 11. 33 is 3 times 11. The 11's cancel. So what am I left with? 2 over 3, 2/3. Number 16. 224 is 2 times 112. 84 is 2 times 41. Is 41 on my chart? Good. So, if I know this is a prime number, then all I do is cancel out the 2's, and what's the answer? 112 over 41, because I know I can't reduce it down. Unless 41 goes into 112 evenly, does it? No. 2 times 41 is 82. 3 times 41 is 123. So it doesn't go into it evenly. All right. Number 18. Any questions? I know we're moving fast, but we have a lot of problems to work today. Number 18. It says 7/3 plus 7/9 plus 5/6. And They want me to use a denominator of 18. So, what do I take times 3 to get 18? 6. So then I take 6 times 7 and I get 42. Everybody follow that? What do I take times 9 to get 18? 2. So I take 2 times 7 and I get 14. What do I take times 6 to get 18? 3. So I take 3 times 5 and I get 15. And I'm adding these together, so I'm going to get an answer that's over 18. And what is that answer going to be? What's 42 and 14? 56. And what's 56 and 15? 66 and 5 would be 71. Everybody follow the process? Number 20 to 82. Operate and reduce. Now, 1/7 plus 1/3. Wouldn't that just be 1/10? Would it? What's the answer? Right or wrong? Wrong. Well, why did you do that? Because it would be so easy. Yeah, but it's wrong. So, we have to learn the right way to do it. And this is why people don't like fractions. Because to add fractions, I have to find a common denominator. That's a common multiple of 7 and 3. Multiples of 7 are 7, and then 14, 2 times 7, 3 times 7, 21, 4 times 7 is 28, and just keep going. You follow me? Multiples of 3 are 3, 1, then 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, 6 times 3 is 18, 7 times 3 is 21. There it is, right there, 21. You go, no, you don't have to do all that work. You can just say 3 times 7 is 21. And that's my common denominator. Then, what do I take times 7 to get 21? 3. So that takes this times 3, so I have 3 over 21. Plus, what do I take times 3 to get 21? 7. Oh, this is wrong. Let's get this off of here. We can't do that. Times 7. So that's 7 over 21. When I add those together, I get 10 over 21. See why people don't like fractions? It's just a lot of work. And I'm sorry, but I look at that, and it just looks like a work of art to me. It's just so beautiful. I could just look at things like this all day long. Well, something wrong with you, Tom. Number 24. At least that's what my friends tell me. 1/12 plus 7/18. Now, you could just go 12 times 18 and get a common denominator, but 12 is 3 times 4, which is 3 times 2 times 2, and 18 is 2 times 9, which is 2 times 3 times 3. So my common denominator has to have 3, 2, 2 in it. It's got that. And then 3, 2, 2, I need another 3 to have 3, 3, 2 in it. So it's got that. Oops, not there. 3, 3, 2. So now my common denominator is 2 times 3 is 6, times 3 is 12, times 2. 3 times 2 is 6, 6 times 2 is 12, 12 times 3 is 36. So my common denominator is 36. So what do I take times 12 to get 36? 3. Take this times 3 and I get 3 over 36 plus, what do I take times 18 to get 36? 2. So I get 14. So the answer is what? 17 over 36. Okay? And it says reduce it. So, but 17's on my list. It's a prime number, so I don't reduce it. There's nothing you can reduce. Number 28. 2/7 minus 3/11. My common denominator is 77. 7 times 11, that would be 22. Everybody follow that? 11 times 7, that would be 21. Then I have 22 of these minus 21 of these. That would give me 1/77 left over when I subtract. So now we've added fractions. We know how to subtract fractions. Now let's multiply some fractions. Oh man, this is why that first one where I said, what's 7/9 plus 3/8? Now, do you see why somebody might say, that's 10? No, that's 10/17. Because here's why some people think that, and that's wrong. But because when you do multiply, you just take 3 times 7 and 9 times 8. When you're doing multiplication, you just go straight across and multiply. So some would say, well, if that's what you do when you multiply, isn't that what you do when you add? And what's the answer? No. You have to find the common denominator for addition and subtraction, but multiplication is just straight across. So you have to write yourself a note and keep those rules straight. And so now, watch what I have. I have 3 times 7 over 9 times 8, but 9 is the same as 3 times 3, so I cancel out one of the 3's. And I'm left with 7 over 3 times 2 is 6 times 4 is 24. Do I see how that works? If you like to know why multiplication works so smoothly, stay after class and I'll show you. But we have to cover all this material, so we'll keep going. Now let's do some division. 2 over 5 divided by 5 over 3 is the same as 2 over 5 times what? 3 over 5. In other words, you take all your division problems and convert them into multiplication problems, but you flip the second number over. You go, why? And I say, because it works. That's why. If you want to know how it works, stay after class and I'll show you how somebody discovered this pattern and just passed it on to the rest of us. So now that means I have 2 times 3 is 6. 5 times 5 is 25. And the answer is 6 over 25. But you understand, with division, you change it to multiplying by the reciprocal. And maybe some of you were taught somewhere in life, division, you invert and multiply. But if you invert and multiply, you're tempted to invert the first number. So it's not invert and multiply, it's multiply by the reciprocal. That's the correct way to say it linguistically. You multiply by the reciprocal. All right, number 38. It's a multiplication problem, so we take -2 times times +4, and we get -8. Then we take 5 times 9, and we get 45. Everybody follow the process? Then let's do number 42. 3/4 divided by -1/5 is 3/4 times 5 over -1. See how you invert that? Then you have 3 times 5, which is 15, over 4 times -1, which is -4. Except when a mathematician sees 15 over -4, it hurts. It's like wearing your shirt wrong side out or something. Isn't this much prettier? So when you look at the answer book, it'll say -15 over 4. Because they always like to put the negative up on the top number. You say, why? Because it looks prettier that way. But the truth is that 15 divided by negative 4 is the same answer as negative 15 divided by 4. So they're both saying the same thing. It's just that one looks prettier than the other one. Number 50. How we doing? Oh, we're in good shape. 1/2 divided by, but see this parentheses? 1/8 divided by 1/4. So I change this division to multiplication and flip it over. Now I have 1/8 times 4 over 1, which gives me 4 over 8, which is the same as 1/2, right? So now I put this 1/2 back down here, and I say now I have 1/2 divided by 1/2 divided by 1/2. And that would be 1/2 times, flip it over, 2 over 1. And then 1 times 2 is 2. 2 times 1 is 1. So 2 over 2. So the answer is, after you do all that work, the answer is 1. And I'm sure in your heart of hearts you go, that doesn't look right. And the guy knows that. So if he had this question on a multiple choice test, he would put 1 as one of the answers, but then he would put something else that would make you feel better. And if you pick the one that makes you feel better, you probably picked the wrong one. So just rework the math and make sure you get it right. Questions? We're on a roll. 56. 1/2. And remember, when it's written in front like that, it means times. So you can just put a little dot there for times. 1/2 times, parentheses, 5/2 minus 1/3. So I'm subtracting these fractions. So I need a common denominator. 2 times 3 is 6. So 2 times 3 is 6. So I take 3 times 5 and I get 15. And 3 times 2 is 6, so I take 1 times 2 and I get 2. Now I have 15/6 minus 2/6. And what's 15 minus 2? 13 over 6. What do you think? Oh, I'm not done yet. So now I come over here and I have 1/2 times 13 over 6. Oh, and we still have this over here, don't we? Minus 5/12. Wow. This is messy. So we do the multiplication. What's 1/2 times 13 over 6? 13 over 12. Then I go minus what? 5/12. Finishing out the rest of the problem. So I have 13/12 minus 5/12. What would that give me? 8/12, and that reduces down to 2/3. See, if you put 8/12 and check the answer, it won't show up as the answer because the instructions said perform the indicated operations and reduce each answer if possible. Questions? Does that seem like way too much work to you for one problem? It just seems like so much fun to me. 60. Problem 60. 5 over 1 divided by negative 5 over 2 is 5 over 1 times 2 over negative 5. Flip the second one up. 5 times 2 is 10. 1 times negative 5 is negative 5. 10 divided by negative 5 is negative 2. What do you think? Number 70. Subtraction. Negative 3/4 minus negative 3. So what do we have to do with this? Put it over 1. Wait a minute. This said negative 3. Why did I put 3 over 1? Because subtraction is the same as doing what? Adding the opposite. Do you follow me? So now I've changed my subtraction problem into addition problem. I could have come out here and said negative 3/4 plus 3. See, I could have done that, but I just, since this is a fraction, I make this one a fraction too. So now I have negative 3/4 plus 12/4. See, how'd you get that? Well, to change from 1 to 4, I multiply by 4, take this times 4, and that gives me 12. So now I have negative 3 plus 12. That gives me 9 over 4. So there's the answer, 9/4. Are there lots of little ways to make mistakes while you're working these? So you see, if you show your work when you're doing them, if you're working these things out on the same paper you're turning in for your homework, then when you turn to the back and grade it, if you missed it, you'll be able to see why you missed it. And if you can't, then just say, I don't know why I missed this one, and I'll probably send you an email and show you how to work it. Number 79. 1/3 minus 1/3 times 2/3 divided by 2/3. What's the order of operations? We do this multiplication and division first, left to right. So what's 1/3 times 2/3? 2/9. So now I have 1/3 minus 2/9 divided by 2/5. So what do I do now? I do the division. 2/9 times what? Flip it upside down. 5 over 2 equals 10 over 18, which is 5 over 9, if you reduce it down. So now I have 1/3 minus 5/9. So I get my common denominator, 9 and 9, and I have times 3. So times 3, 3/9 minus 5/9 equals negative 2/9. And that was fun. 84. 84? Where did I go? Oh, 84. There it is on the next page. Applications. Applications. See, when I see all those words on page 267 for problem 84, I go, let's shorten this up. So it says a human brain, HB, weighs 3.18 pounds. That's the average human brain, isn't it? And Anatoly France's brain weighed 2 1/4 pounds. Is that what they said? How much under the average was Anatoly's brain? Well, I take 3 1/8 minus 2 1/4. 3 1/8 minus 2 1/4. But I change this to eighths, so now I have 3 1/8 minus 2 2/8, because 1/4 is 2/8. Now I've got common denominators. I can do the subtraction. 1 of these minus 2 of these. Can you subtract 2 from 1? No, you have to borrow. So this becomes 2. And then that means I have 8/8 plus 9/8 plus 1/8. That makes 9/8. So now I have 2 9/8 minus, I don't know why I put that line in there, 2 9/8 minus 2 2/8. So the answer is 7/8. Everybody follow that? Questions? 86. A board is 3/4 of an inch thick. So here's my board that's 3/4 of an inch thick. It's glued to another board that's 5/8 of an inch thick. So here's my other board that's 5/8 of an inch thick. And the glue is 1/32. So here's the glue that's 1/32 thick. And what do they want to know? How thick is the result? How thick is the result? That would be 3/4 plus 1/32 plus 5/8. Everybody follow that? So I have 3/4 plus 1/32 plus 5/8. My common denominator is 32. So I take 4 times 8 and I get 24. And 1 times 32, 1 times 1. I guess I should do 8 times 3. And then that gives me 1. And then 8 times 4. So I take 5 times 4 and I get 20. So I have 24 32s plus 1 32, that's 25, plus 20, that's 45 over 32. But I can reduce that down. 45 is 5 times 3 times 3, and 32 is 2 times 4 times 4. No, it isn't. I can't reduce that down because nothing reduces. So that's my final answer right there. It just looked to me like I could reduce it down, but I can't because I factored it out, and there are no common factors to cancel. All right. Questions? Number 88. What does it say? Human bones are 1/4 water, 9/20 mineral, and the rest is something. Where'd I get over 20? Because what's my common denominator for 4 and 20? 20. So I put 20, 20, and 20. And 1/4 times 5, so times 5, would be 5/20. 9/20 would be 9/20. And then this would be question mark over 20. And all of that added together would equal the whole thing, and the whole thing would be 20/20. Everybody follow that thinking? So what would I have to add? Well, 5 20s and 9 20s would make 14 20s. So 14 20s plus what? Would equal 20 20s. 6. So the answer is 6/20. But what happens? Can I reduce down 6/20? So what fraction is the rest? 6/20. But I can reduce that down to what? 3/10. Everybody follow the process? So if you said this is my answer and you checked it and say nope, the answer is 3/10, do you see how all you'd have to do is just write yourself a note and say I forgot to reduce it down? Because 6/20 does equal 3/10. Number 90. Have you figured out that if I don't see your homework on this assignment, I'm not going to give you credit for it? You need to show me what you're doing, because I know you can't do this in your head. Number 90. Americans work an average of 46 3/5 hours a week. And Canadians work an average of 38 9/10 hours a week. How many more hours per week do Americans work? So how many more? That's what we're looking for. So we take hours, 46. Why did you say 6/10 instead of 3/5? Why did I change this to this? What am I doing? Getting a common denominator. And then minus this, and what do I get for an answer? 6/10 minus 9/10. I can't do that. So I change this to 45 and 45 and plus 10/10. That would be 45 and 16/10 minus 38 and 9/10. And what's 16/10 minus 9/10? 7/10. And what's 45 minus 38? 17. There's my final answer. We work a lot more hours than they do in Canada. Okay, so I don't mind. Number 92. What's this all about? In problems 92 to 101, refer to the diagram below. So 92 says, what fraction of the hour is weather? So put your pencil at 0 and start going around to the right till you come to weather. Where does weather start? It starts at 9 and goes until when? 12. Everybody see that? Just put your pencil on the paper at 0 and start going around to the right till you come to weather. And weather is from 9 to 12. That would be 3, wouldn't it? No, that wouldn't be 3. What would that be? 10, 11, 12. Oh, that's right. It's not 4. You don't count 9. It's 9, 10, 11, 12. It's 3 minutes. Then I keep going. News and beyond. Whoops, here's weather again at 19, and it goes to 22. So what's 19 to 22? 19, 20, 21, 22. That's 3 minutes again. Then I go from 22, here's traffic, news and beyond. Weather from 29 to 30. There it is again. Weather 29 to 30. 29 to 30, that's 1. Okay? Then I keep going around till I come to weather again. 39 to 42, that's 3. Are we finished with this thing yet? No, we have to go all the way back up here. 49 to 52. 49, 50, 51, 52, that's 3 again. And then 59 to 0, that's 1. So, how many minutes? 3 plus 3 plus 1 plus 3 plus 3 plus 1. What's that add up to? 6, 7, 10, 14. But they didn't ask how many minutes are weather. I've got 14 minutes. They want to know what fraction. And that would be 14 over what number? 60, because there's 60 minutes in an hour. And that reduces down to what? 7 over 30. So 7/30 of the hour is spent on weather. And if I was as accurate at math as the weatherman is at predicting the weather, I probably wouldn't have a job. I can't believe those guys get away with making so many mistakes. Sometimes they're pretty close. They like to talk about how accurate they are. Well, they miss a lot of it. Number 96. Which of the features uses the most time? Now, see, which uses the most time? I look at that picture and I'm going, it looks like news uses the most. Or no, is it news and beyond? And I go, news is what? 0 to 8? That's 8, not 5. And then come around here till I find news again, and it's 30 to 36. That's 6. Do I see news again? Nope. But news and beyond, I come around, and that's from 12 to what? 19? That's 7. News and beyond, 23 to 29. That's 6. News and beyond, 42 to 49. That's 7. And news and beyond, 53 to 59. That's 6. So this adds up to 13, and 13 is 26 over, and they want to know what fraction, so it's 26 over 60. So that's a lot more than 14. So that reduces down to 13 over 30. So News and Beyond has the most, and it's 13/30. Almost half of the hour is News and Beyond. And stop when you get to problem 97. 97 is the last one. Work 97. And that's the last one you work. Okay, any questions? I know we're done a little early, but for those who need to correct their test, I have your exams here somewhere. I'll find them. And for those who have, if you start working on your homework, some of you probably have questions about, stumped on one of them that you missed. I'll be sitting down up here to help you with it just as soon as I get this computer turned on.